What's up guys, welcome back to another video here at Chief Academy, and today we'll be going through circle theorems. Please like and subscribe if you haven't already, because I promise you, it is this easy. Our learn outcomes for today is to understand what circle theorems are and when to use which one in an exam. It's also to solve circle theorem exam questions. So, what are circle theorems? Circle theorems are properties that show relationships between angles within the geometry of a circle. We can use these theorems along with prior knowledge of other angle properties to calculate missing angles, without using a protractor. This has very useful applications within design and engineering. In this lesson, we will focus on solving circle theorem exam questions and understand the 7 different methods. So, there are 7 different circle theorems, but here are 6 of them as we'll look at the tangent separately. As you can see, most of them link to triangles, and circle theorems will come up on at least one of your papers. So it's vital that you understand. So, the alternate segment theorem is the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. When using the alternate segment theorem, in your working out, you just state because of alternate segment theorem. The other ones say with angles in the same segment, you need to say angles in the same segment are equal. But for the alternate segment theorem, you just need to say because of alternate segment theorem. We just went through the same segment theorem. The chord of a circle, the perpendicular from the center of a circle to the chord bisects the chord, and this means it splits the chord into 2 equal parts. Angles at the center. The angle at the center is twice the angle at the circumference. This is quite a popular one and will come up a lot. Angles in the semicircle. The angle in the semicircle is 90 degrees. So if you have a diameter and you drew 2 lines, you will end up having a right angle triangle, as shown here. And then a cyclic quadrilateral, the opposite angles in a cyclic quadrilateral total to 180 degrees. And that is also a quite popular one. I say the main ones you need to know is the angles in the same segment, angles in a semicircle, angles at the centre, and a cyclic quadrilateral, along with alternate. Chords of a circle doesn't really come up that much. Tangents to a circle can come up in other areas of maths, such as area of a circle, which is why I've separated them. Most of the higher end circle theorem questions of the recent years have involved tangents to a circle, so make sure you understand this theorem. In diagram A, the angle between a tangent and the radius equals 90 degrees, and in diagram B, tangents what meet at the same point are equal in length. As you can see in diagram B, it makes a kite. Once again, it's that time to have a go at some Maths Genie exam questions. Have a go, pause the video, and unpause when you've done. So, in our first question, B is a point on the circumference of a circle, with the centre O. AB is a tangent to the circle. Angle BOA equals 72 degrees. Work out the size of the angle BAO. You must show all your working. So with circle theorem questions, you need to write out your working using words as well. So OBA equals 90 degrees, a tangent meet radius at 90 degrees. And then if we do BAO equals 180 minus 90 minus 72, as angles in a triangle sum to 180, meaning BAO equals 18. In our second question, A, B, C, and D are points on the circumference of a circle. Angle BOC equals 66 degrees. Find the size of the angle BAC. And as we can see, it's the angle at the centre and angle at circumference. And the angle at the centre is double the angle at the circumference. So the answer is going to be 33, and the reason for our answer is the angle at the circumference is half the angle at the centre. And you can word it the other way around, saying the angle at the centre is double the angle of the circumference. Circle theorems may be taught at a grade 6 level, but they can be included in many high grade questions at the end of your papers. The higher the circle theorem question is, the more likely it is a proof question, and you will have to write your working out in sentences. Circle theorems link to many other areas of higher maths, such as triangular mathematics like sine, cosine, and congruent triangles, and carrying on. So it's important that you understand circle theorems, as it can be worth big marks in your exams. Here is another exam question for you to have a go at. Have a go, pause the video, and unpause when you've done. So, A, B, and C are points on the circumference of a circle with the centre O. DCE is a tangent to the circle. Angle ABC equals 61, angle ACB equals 73, and angle BCE equals x. Find the value of x and give reasons for each stage of your working. So, BAC equals 46 degrees, as it's 180 minus 73 minus 61, as angles in a triangle sum to 180 degrees. Now, if you spot this, well done, because it's quite hard to spot if you've not done it before. But that also means x equals 46 degrees due to alternate segment theorem. If you have spotted that, very well done, because that's quite hard to spot if you've never done it before. But as you can see, we have this segment here from B, C to E, but we also have the segment of C, A to B, and they are in alternate segments. So we can use the alternate segment theorem. So our final answer for x is just 46 degrees. Now it's time to have a go at some of the hard exam questions you'll probably be asked on circle theorems. Have a go, pause the video, and then pause when you've done. So, A, B, C, and D are points on the circumference of a circle with the centre O. Angle BOD equals x. Find the size of the angle BCD in terms of x and give reasons for each stage of your working. As you can see, and as we've been told, A, B, C, and D are points on the circumference, meaning it's a cyclic quadrilateral. So we're going to use that knowledge with other circle theorems to find out B, C, D. So, BAD equals the half of x, as the angle at the circumference is half the angle at the centre. And then BCD equals 180 minus the half of x, as opposite angles in a cyclic quadrilateral sum to 180. Here is another exam question for you to have a go at. Have a go, pause the video, and unpause when you've done. So, C, D, and E are points on a circle with the centre O. AEB is a tangent to the circle at E. CD equals DE, and angle AEC equals x. Find the size of the angle OED in terms of x and give reasons for each stage of your working. So let's plot on what we already know. We know AEC equals x, and we know that CDE is an alternate segment. So we can use alternate segment theorem for the angle of CDE. Now, we also know that CDE is a triangle, but we know CD is equal to DE, meaning it's an isosceles triangle, meaning CED equals 180 minus x divided by 2, as angles at the base of an isosceles triangle are equal. So, we can now work out OEC to be 90 minus x, and DEA equals 90 as tangents meet the radius at 90 degrees, because we know AEB is a tangent to the circle. This means if we use all our information given to us, OED is going to be 180 minus x divided by 2 minus, in brackets, 90 minus x. That would mean OED equals 90 minus a half of x minus 90 plus x, giving OED to be a half of x And that is all the stages of our working out. And that is our final answer. That is, I'd say, a grade 7, near a grade 8. But the grade 9 questions on circle theorems can be a lot harder than this. So if you're struggling on this, make sure you revise circle theorems. And that, ladies and gentlemen, is the end of today's lesson. And I did say it was that easy. Thank you very much for watching. Please like and subscribe if you haven't already, and I will see you in the next one. Goodbye.